All right. Hello, everyone. So, putting together another video here. This one is going to be focusing on expanding on what we've learned in previous videos. So, previously, we looked at how to just create simple programs. We looked at how you can import standard Python libraries or packages. We've looked at how you can create your own Python files and import them into a project. So, this one is going to focus a little bit more on how do we import some of the complex packages out there that aren't part of the standard library collection. And to do that, we use something called the package installer for Python, or pip, PIP. So the first part of this video, they're going to be really short, talking about what exactly pip is, how we use it, some of the basic commands, and then we'll get into actually looking at one of the packages out there, in particular the cryptography package, and how do we install that, how do we use it, and write some code. It's a little bit more complex topic than the ones we've done previously. So some of the code is already pre-written just to save time, so this video isn't like an hour long. So to get started, we're going to look at what exactly is pip. So if you've installed Python on Windows, if you watch the first video I put out there, it gave you an option for installing package manager. If you did that, then pip should already be installed with it. Again, this is focused on Windows specifically. If you want a follow-up video on using this on Linux, we can do that in the future. Just leave a comment below. So to get started, what exactly is pip? So it's allowing you to install packages that other developers have put together so that you can reuse their code. So to get started with that, one thing I want to do is show the basic command. So you use the pip keyword, and then you can use something like freeze. So freeze is a keyword, and what it'll do, it'll take your current packages that you've installed using pip, and it'll print them out. In this case, my default Python installation has nothing. Now, to install something, you would use pip install and then the name of the package. So a lot of this deals with Googling, trying to find out what packages exist, what the proper names are. There really is no good lookup with pip. So it just kind of comes with trial and error. But the one we're going to use today is cryptography. So if I hit enter right now, it'll go through and download all of those required files to run the cryptography package and install it on my machine. However, this can cause problems doing it this way, because if you install it by default, just using pip install from the terminal, it's going to install it so that it is installed for all Python implementations. Another concept that we're also going to touch on here is the concept of the Python virtual environments. So Python knows that developers may have certain packages that they want to use for specific projects, and sometimes those packages don't necessarily agree with each other. So you can create a virtualized environment, kind of like a container for the code, and when you're inside that environment, you can install packages that won't impact the rest of your Python installations. So to do that, you do Python tech or -m venv for virtual environment, and then give the virtual environment a name. In this case, I'll call it my venv. And when we do that, on Visual Studio Code, you saw something pop up over here, and it installed some directories already. The command is the same on Linux and Apple computers, Macs, but the next part is a little bit different between the two or three. So you see, I don't have a prompt yet. It's still going through the process of creating the virtual environment. And sometimes if you're using Visual Studio Code, it'll try to add in some additional functions, some capabilities with the virtual environment. So sometimes a little bit slower. So I should get a prompt back here in just a second. Okay, there we go. All right. So now it created the virtual environment. So we need to enter the virtual environment now. We need to activate it. So in Windows, the command you do that is you look at the name of the virtual environment you just created. So it's my VENV. Then you go in there into the scripts directory. And then you type in activate. Notice over here now we have a my VENV in parentheses. That's to indicate that we are now inside of the virtual environment. Again, I can do a pip freeze. And right now we don't see anything. Again, that's just because we haven't done anything specific with his environment. But what we can do is pip install cryptography. And it's going to grab all the dependencies, it's collecting them, it's installing them. And once that's finished, if we do pip freeze again, you can see all of the supporting packages that have been installed. So now you can see that gave this output. One thing that people commonly do once you have your code finished, we'll just do it now to demonstrate. But if you do pip freeze and do a little right arrow and do requirements.txt. So if you see anybody talk about the requirements.txt file, that's what it's talking about. It just saves all of the code that is required, or all the libraries that are required, the dependencies for Python, to basically let your code work on other machines. And then if you wanted to, on another virtual environment, you can install that requirements.txt file. You do like pip install -r and then give it the requirements.txt file. But since they're all already installed, we're not going to do that right now. Okay, one last thing on that is if you deactivate, just type in the keyword deactivate, you can see that the virtual environment went away. And if we type pip freeze again, we'll notice that we don't see anything because, again, those packages we installed are only inside of our virtual directory. So we'll go back to our environment, reactivate it again. And our dependencies are listed. Okay. So we're going to look real quick at this cryptography library, this package. So you can find the details on it at cryptography.io. And by default, what it tries to import is some, I believe it, symmetric encryption. One of the things we want to look at specifically is we're going to look at using this for RSA encryption. So asymmetric, not necessarily encryption, but for digital signatures is what we're going to look at. So asymmetric, you have a different private key and a public key. So you keep your private key public or private, only you know about it, but anybody can have your public key to validate the information that you sign with a private key. So you can look at the documentation here if you get confused, but specifically we're going into the primitives, and inside of primitives, the asymmetric algorithms. And then from there, there's a couple different that are supported. We're going to go into RSA. And most of the information of the code that I have, I've pulled from here for the demonstration. We'll take a look at what this does, and then kind of run it locally, and then show what happens when we change some of the code, some of the parameters to see how it breaks and what how it works in general. So the first one shows you how to just basically create your private key. It tells you what exactly you need to import, and then uh, the code that's required. So you call in their built-in generate private key function. You pass in an exponent and a key size. It also tells you how to load a serialized key. So basically, once you create your private key, you can save it to a file, which we'll go over in a little bit. And then you can reload that file and then have your private key used for later. In this section here talks about exactly how you serialize it. You save it, you format it so it can be saved. So again, it's just taking the private key and a private key bytes. You pass it an encoding parameter, a format, and then if you want to have encryption, you can pass in the encryption. Or there's actually an option to not have any encryption. And then it shows you how to get your public key as well. Same thing, you can pull your public key off of your private key with a special public key method. You can serialize it, and then again, you can download that as well, save it to a file. The other piece of that is also signing. So you provide a message as a byte format, what you want to sign. You take your signature, which comes from your private key. You pass in the message, some padding, and then pass in the SHA-256 algorithm for the padding. And then once it's signed, you can verify. So the opposite of that is using your public key to verify by passing in the signature, the same message, and same padding mechanism. So I took most of that code and I put it into this file here. So normally you have your import at the top of the file. Here, just because I grabbed some of the code directly from that web page, it's separated out just so you can see how we're using it here. So this first one is all we're doing is we're creating a private key. We have the second one here where we're creating a PEM file and serializing it. So what we've done next, you've seen this in the previous videos, is we're opening our file. In this case, we're calling it mykey.pem. We're writing it, so that's W, and B indicates that we're writing it as bytes. We're writing our PEM file, so the private bytes, and then closing it. And then right after that, we're just reading it, again, saving it to our private key. We're using that load PEM. We're reading and we're passing in the same password. From there, we're going in and showing how we sign. Again, we have the message we want to sign. We're passing in, we're using our private key.sign, passing in the message, passing in padding, and then we're using our public key to verify it by passing in the signature that was saved up here, the same message, and the same padding mechanism. And then the last piece here is just showing how we save or print out the public key, what it looks like. So let me go ahead and just run this real quick. So this printing out here is just this print statement at the end. It's actually printing out what the public key looks like. But if we follow through what this is doing, first thing it did is it opened this mykey.pem. And this is what the private key looks like when it's saved to a file. We then opened it and then, just loaded it just to show it can be loaded. We created a message. So here's what I want to sign. And then we validated it. So we didn't see anything here. So by default, if the verification passes, the program just continues. So now we're going to try to break this. So first thing first, when we created our file, we saved it with a password. So we just called it my password. When we loaded it, we had to pass in that password as well. So I'm going to change this and then put in, an exclamation point here at the end so the passwords don't match. And we're going to rerun. And you see that we get an error because it's going to decrypt it because it's a bad password. So that's one way to protect the private key. The other thing we're going to do here, again, since I saved the password back, it should work properly. Here's the message we want to sign. Now I'm going to change the message. In this case, all I'll do here is add a period at the end. So we get a invalid signature being thrown because it doesn't match exactly. So that's one way to validate that when somebody signs something with a digital signature with their private key, if the content has changed or if the signature itself has changed, then you can determine that the change has occurred by doing the verification using their public key. Okay, so we'll put that back. So this is all well and good. How exactly do we use this for something more complex? So the second demo, I'm walking through the process. And let me take out this here. So I've consolidated all the imports that we're going to need. Again, we're still using that same virtual directory or virtual environment. I added a couple more here, which we're going to take a look at. But that's more so to just support the advanced functionality here. And what I've done is I've extracted some of those components into different methods. So in this case, we have a method to load a private key, which takes in a username and their password. Just printing here, I can get rid of that. I created a separate folder to store the private key. And I also have a separate folder for storing all the public keys. If that public key already exists, it's going to just use the code that we had previously to deserialize it. And it's going to decode it with the password and return the private key. We also have a method to sign by passing in a message and a private key and returning the signature. We also extracted it out as a verify the message. Again, in this case, we're opening the public key for the username. We're reading it. We're loading the public key. And then we're using the verification for the signature we provide, as well as the message. And then we also have a method here to create a brand new key. When we're creating a key, so what that process is going to do, it's going to first go into that my private key folder, look for a folder or a file with the username .pem, and it'll write after it's created the private key with a password that we've given it. It also extracts out the public key and then writes that to this public key directory. All right, and then from here, this is kind of the start of the code. So the first thing it does is it asks the user for their username. It uses this exists method, which is part of the OS library, one of the standard inputs in imports. And it'll say, I'm going to look inside my private key under that username we just provided, .pem. And if it exists, so this is a conditional statement in Python. If it does exist, then it's going to ask for the password, and then we're going to load that private key, calling the method we looked at above. Otherwise, we're going to, again, take a password and then create a brand new key. From there, we're just demonstrating something we've done before. We're creating a JSON object, or an object that's going to be converted to JSON. And it's just taking a name, a gender, and then we're also creating a content component. We're storing inside that content all the stuff we just added for the value. And then we're doing this because now we're going to sign just this part, just the value, the name and the gender, store the signature as hex into a signature file or signature component, and then take that signature and add it to the overall content. So basically, we have nested JSON here. We have part of it that has the content, which includes this, and the signature. So what this allows us to do is essentially create something in a file where the content up top, the value up top, can be saved into a file with the signature. And then we can know immediately if someone tampered it, because if it did, then the content that we pull in when we're doing the verification under value will not match with the signature that it was signed with. So we're going to take a look at this real quick and run it. So we'll watch as it creates. Oh, it's going to prompt for a username, so we'll call Bob. Password ASDF. So it created a public key for Bob. It created a bob.pem file for the private key. And then it also created this myfile.json, which has, again, this section here is, kind of a subset of JSON, just including Bob and gender. And then we have a signature from signing this, and that is stored here as well. So we have inside of our JSON a value and a signature component. And we can see it down here as well. So if we do something here, and let's say I comment out some of this code, actually, I'll just put in a pause here. Again, if you saw from my previous videos, this is just one way to stop the execution temporarily so I can make some changes. All right, so it's currently paused at this point before we verify the message. So I'm going to go in here. Actually, that won't do anything. Apologies. We want to have a pause before we open the file so that I can edit it. All right. So now, if I go into myfile.json, Bobby, you'll see we get the invalid signature. So we know that something has happened to this file, and it's no longer the same file that was originally saved. Similarly, what we can do is I'll run this again. And let's say we change this, what's a C to a B. Again, invalid signature, because that signature, when we convert it back to bytes and we take this message and we try to validate against it, doesn't match. Okay, so one other thing here. So if we run it again, the last thing I want to show is if I do like Joe. So we created a new file, and we also have a new public key for Joe. So this could be expanded even further so that you can have a whole set of different users that have to log in with their username and their password, that they can sign messages, that they can save them here, and then people can validate if you include what exactly, who signed it. So let's say we modify this with one more field. So we can see that we also have Bob here. So what we can do is if somebody else wants to extract this message, they can pull out this field, Bob, go into a public key, look up the public key for Bob, and then use that for the validation of the message, even if that person's not logged in. Just to save time, I'm not doing that here, but that's something that could be done as an exercise. So if you've liked what we've seen here, if you have suggestions for change, if you liked it better when I was stepping through the code one at a time, let me know in a comment. If you like it this way better, again, leave a comment. Anything else you would like to see, leave a comment, and I will try to accommodate that. More videos coming soon, so please stay tuned.
Good news, everyone.
That's right. Good news, everyone. This is Doc here. Made it to the end of the video, which means you liked it. So please click on the thumbs up below the video. If you have any comments, anything else you'd like me to see put a video together for, leave a comment, ask any questions. And of course, more videos like this are coming, so be sure to subscribe.